this is Chrissy from the Hickory Corner Branch Library. I recently made a Story Stretchers video where I did a yoga program using the story, The Little Red Hen, and I read the book, The Little Red Hen Makes a Pizza. Now, one of the ingredients that the Little Red Hen used is yeast. It's a little packet like this. She was using to bake her bread or to make her pizza. Well, I want to show you how we can use yeast to do a really cool experiment. Actually, it's a really warm experiment, not really cool, because it creates an exothermic reaction. What's exothermic? Exothermic means it's going to get warm, it's going to get hot as the reaction occurs. So, the ingredients we're going to be using, we don't want to touch too much with our hands. So if you have gloves, if you have safety goggles even, that would be great. I don't have either of those right here, so I'm going to be very, very careful as I show you how to do this. So what you're going to need is hydrogen peroxide. So hydrogen peroxide comes in different volumes or different percentages. So at home you probably have like the 3% hydrogen peroxide, which is 10 volume. That is completely fine. You could use that for this experiment. And actually I do suggest that if you have children that are doing the experiment and you're using a smaller water size bottle, I would use the 3%. But since I want a bigger reaction here, I'm going to use 40 volume. So I'm going to use this one here instead. So this is much stronger hydrogen peroxide. So I got to be very careful with it. So I'm going to use a funnel to pour it into my bottle here. Now the size of your bottle is going to vary depending on the strength of your hydrogen peroxide. So in this case, I have a 1 liter bottle. You can use 1 liter or a 2 liter bottle. If you're using just a 3%, then you're fine with just a regular size water bottle because we do want the reaction to come up out of the bottle. So I have a 1 liter bottle here I'm using, and let me pour in half a cup of my hydrogen peroxide. Now, actually, before I do that, you can do this in either way. It's probably a little easier to see if before I add that, I put in the dish soap, because we're going to use a little bit of dish soap too. This is going to help create some bubbles later. So I'll just put that in now, just so we can see that easier. So I just put some dish soap down at the bottom, a few squirts of that. Now I'll add my hydrogen peroxide. And I don't really want to get this on my skin. It could sting or burn, so that's why I said if you have gloves, you might want to wear them. So there we go. So you can already see some bubbles formed there, and that's completely fine. We can kind of swirl it together a little bit if we want. And if you wanted to add food coloring, you want your reaction to be colorful, you can add food coloring now, and then you would swirl that up with that. I am going to add food coloring, but I want to do something a little bit special. I want to do something patriotic, so I'm going to use 2 different colors, red and blue, and try to make stripes with mine. So this is very difficult to do. Not that it's difficult, but you have to be very precise with making the stripes. I don't want to swirl it together, okay? Especially because right now, yeast is like gold. It is very hard to find. This is my only packet, so I can't make any mistakes. So if you're watching this video, that means great. I did it and we managed to get through this without a mistake. If you're not watching it, then obviously I'm just talking to myself at this point. I'm actually going to just check the temperature of my water right now to see if I'm about where I want to be. We're going to be using very warm water for our yeast. The perfect temperature for yeast is about 110 to 115. So if it's hotter than that, like if it's about 120, it starts to kill the living organisms in the yeast. And if it's up to about 140 or higher, it's just outright, they're not going to rise. So right now I'm pretty good. I'm at 117. I still have a couple minutes till I get to that. So I have my hydrogen peroxide. I have my dish soap. And now I'm going to add my food coloring, my stripes. So I'm going to do a blue. And I'm tilting this bottle because, like I said, I want to try to make stripes. So blue. And it's okay if it's not perfect. Red. Blue. Red. Okay, so now I'm going to mix up my yeast. I'm going to open the packet and pour it into my water. It's a half a cup of water. Like I said, very warm water, not hot water. If you have a meat thermometer you want to test it with, you can do that just to see if you have the right temperature, especially if you're like me and you only have one packet of yeast and this is it. You have to be sure it's going to work. Okay, I don't know how much my stripes stuck around. Let's give it a try and see. So I'm going to move this a little bit. You're going to see why I have this big pan in just a minute. And now I'm going to pour our yeast in. Just giving a little bit of time for them to really kind of get activated and start to work. Like I said, yeast is a living organism. So normally in your bread or pizza or any kind of dough you're using, it will feed on the sugar. So it kind of breaks up the sugar. In this case, it's going to separate the hydrogen peroxide into oxygen and water. So let me pour this in and then we'll discuss what exactly happened. Now I pull the funnel out right away because sometimes it's really fast and other times it takes a little bit. Sometimes it explodes up and sometimes it just oozes out like this, like toothpaste, which is why this experiment is also called elephant toothpaste, because it oozes and oozes like you're squeezing it right out of a tube. So it's really cool to see. But like I said, this is creating an exothermic reaction. So this exothermic reaction means that this foam here is really warm. So I don't want to touch it. Like I said, it could sting or burn my hands. Could even leave little white spots from the hydrogen. So I mentioned how the hydrogen peroxide was going to separate. It was going to separate into oxygen and water, because hydrogen peroxide is very much like water. We call water H2O. Well, hydrogen peroxide is H2O2. It has an extra oxygen molecule. So what happened there is the yeast was like a catalyst. It means it made something happen. It made a chemical reaction happen. And that's because of an enzyme in the yeast called catalase. So the catalase actually separated the hydrogen peroxide. It separated it into the water, H2O, and then that extra oxygen got trapped in the soap bubbles and came up out of it. And as it was doing that, as it was separating, it generated heat to do that. So this is the experiment using yeast. We could see how the yeast would rise, and we got to see how to make elephant toothpaste. So have fun giving this a try at home if you can get your hands on some yeast.